Okay. Good morning, students. ನಾವು ನಿನ್ನೆ electrostatic potential capacitance ಅಲ್ಲಿ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಅನ್ನು ನೋಡಿದ್ವಿ. ಏನೆಲ್ಲ ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೇವೆ ಅಲ್ಲಿ? We studied there electrostatic potential difference, and one more thing, electrostatic potential energy. Now question is, what is difference between electrostatic potential energy and electrostatic potential? Let me write electrostatic potential okay. Electrostatic potential is defined as it's a work done in bringing unit positive charge from infinity to point under consideration against your electric field. That is, we represent electrostatic potential by symbol V. V is equal to, it's a work done per unit charge. We represent unit charge by Q naught. Work done in bringing unit positive charge from infinity to point under consideration. Of course, without acceleration, only kinetic energy irrelevant. Okay, kinetic energy in the first thing. Second thing, against electric field. These 2 points are very important. ಇವೆರಡು ಪಾಯಿಂಟ್ ಏನಾಗಿದ್ದಾವೆ, ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿದ್ದಾವೆ. Okay, this is all about electric potential. We can write electric potential as V is equal to, okay, some constant k, say charge divided by R, where R is distance, or we can write it as V as a function of R. R is distance. It's a function of distance. V is electric potential. ಇದರ ಡಿಸ್ಕಷನ್ ಮಾಡುವ. ನೀವು ಗೊತ್ತಿರಲಿ, electric potential we can write it as VR is equal to K. K is constant, we know. K value of K is 1 divided by 4 by epsilon naught. Correct? Q is charge divided by R. R is distance between 2 point charges. Okay. Now, this is the expression for, we are going to derive this. This is the expression for what? Electrostatic potential. That electrostatic potential. We have one more term. Electrostatic potential energy. Electrostatic potential energy. We represent electrostatic potential energy or simply potential energy. Electrostatic is a field, okay, it's potential energy. We represent it by U. Of course, U as a function of R, which is equal to source charge, test charge, say Q naught, divided by R and K. K is constant. Okay, of course, let me write it very systematically. UR is equal to K into Q naught divided by R. Okay, what is the difference between these two equations? Very important as far as the CET all this concerned, exam concerned. We can define electrostatic potential energy per unit charge is electric potential. Alva, divided by Q naught ಮಾಡಿದ್ರೆ you get same equation. Electrostatic potential energy per unit charge is called electrostatic potential. Confuse ಮಾಡ್ಕೊಳ್ಳ. Electrostatic potential ಅಂದ್ರೆ ಏನು? It's a work done in bringing unit positive charge from infinity. I'm using unit positive charge from infinity two point under consideration. ಇಲ್ಲಿ ನೋಡಿ ಇದು ಯೂನಿಟ್ ಚಾರ್ಜ್ ಇದು 1 ಆಗ್ಬಿಟ್ರೆ ಆಟೋಮೆಟಿಕಲಿ ಎರಡು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಸೇಮ್ ಆಗ್ತವೆ. ಎರಡು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಗ್ತವೆ ಸೇಮ್ ಆಗ್ತವೆ. ಅದಕ್ಕೆ ನಾನು ಹೇಳಿದೆ we can define electrostatic potential energy as ಏನಂತ you can define this electrostatic potential as electrostatic potential energy per unit charge. How does that define? Okay, what is electrostatic potential energy? It's the energy stored. It's the energy stored in a charge when it's brought from infinity to some point under opposite to the electric field. You can define in this fashion also. Correct? Okay. Please remember these two. You will derive it in later class, later session. Now, we have even discussed potential difference. Potential difference. Of course, it's a electrostatic potential difference. Okay. Electrostatic potential difference. Let us consider the charge, source charge and force Q, and some infinity, some point at infinity. Now let us consider 2 points. Say A, this one is B. Electric potential at this point is VA. Actually, we have discussed all those things in yesterday's class, but just a revision. Okay, this is VB. Okay, now what is potential difference? Electrostatic potential difference. Electrostatic potential difference andre enu? Suppose that you place your test charge here initially. ಮೊದಲು ಏನು ಮಾಡ್ತೀರಿ ನೀವು ನಿಮ್ಮ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅನ್ನು ಇಲ್ಲಿ ಇಡ್ತೀರಿ. ಓಕೆ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ತರಬೇಕು. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ತರಬೇಕು. ಇದು ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ, ಇದು ಲೋವರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ತರಬೇಕಿದ್ರೆ ನೀವು ಎಷ್ಟು ಕೆಲಸವನ್ನು ಮಾಡ್ತೀರಿ? Work done by you in bringing that unit that charge from A to B, WAB, or A to B, A to B, A to B against electric field, of course, which is equal to VB minus VA. Here you are bringing this charge. Is nothing but your electric potential difference. Electric potential difference. Okay, you may write it as delta U. Delta U. Okay, this is all about electric potential difference. Fine. Even one step from the over, like SI unit of electric potential and electric potential difference. ಎರಡರದು ಏನು? ವೋಲ್ಟ್ ಅಂತ. ವೋಲ್ಟ್. Volt is SI unit of electric potential and potential difference. Okay, of course, electrostatic potential difference. Both are scalar quantities. Both are scalar. Okay. Again, we know V is given by W by Q, correct? Or Q naught, whatever it may be, where V is electrostatic potential. Now we can write V is equal to W. SI, it is Joule, Joule, J. Charge, C. Joules per coulomb, which is equal to volt, which is equal to volt. Now question is how to define this volt. Define 1 volt. Question ಆಗಿರಬಹುದು. Exam ಗೆ ಪ್ರಶ್ನೆ ಆಗಿರಬಹುದು. Define 1 volt. ಅರ್ಥ ಆಗ್ತದೆ ಅನ್ಕೊಳ್ಳಿ. Getting? Okay. 1 volt. Please define one. We know V is equal to W by Q, Q naught, okay, joule per second, I mean coulomb. If W work done 1 joule ಆದರೆ and if charge under consideration is equal to 1C, then V is equal to, put these values in this equation, what we get? V is equal to 1 volt. Is it? 1 volt. How to define ಮಾಡೋದು ಹಾಗಿದ್ರೆ? When 1 joule of work is done in bringing 1 coulomb of work, 1 coulomb of charge from infinity to point under consideration at some point against electric field, then its electric potential is said to be 1 volt. Its electric potential is said to be 1 volt. Its electric potential is said to be 1 volt. Okay? Let me write systematically. Okay, now somewhere here 1 volt is defined as if 1 joule of work is done in bringing, in moving 1 coulomb of charge from infinity to point under consideration against electric field, then electric potential, stored electric potential is said to be 1 volt. Okay, please remember this. Okay. ನಿಮಗೆ ನೋಟ್ಸ್ ಅನ್ನು ಕಳಿಸ್ಕೊಡ್ಲಾಗಿದೆ, ಯೂಟ್ಯೂಬ್ ನೋಟ್ಸ್ ಅನ್ನು ಕಳಿಸ್ಕೊಟ್ಟಿದ್ದೇನೆ. ಓಕೆ, ಇದು ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ನೋಟ್ಸ್. ಅದು ನೀವೇನು ಮಾಡಬೇಕು ಅಂದರೆ ಎಷ್ಟೆಷ್ಟು ಕ್ಲಾಸ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ ನೋಟ್ಸನ್ನು ಬರ್ಕೊಳ್ಬೇಕು. ಏನು ಮಾಡಬಾರ್ದು ಅಂತಂದರೆ ಈ ನೋಟ್ಸ್ನ ಒಂದ್ಸತಿ ಬರ್ಕೊಳ್ಬಾರ್ದು. ಮತ್ತೆ ಬೈ ಸಮ್ ಮೀನ್ಸ್ ಲೈಕ್ ಟೇಕಿಂಗ್ ಪ್ರಿಂಟ್ ಔಟ್ಸ್, ಮೇಕಿಂಗ್ ಸಮ್ ಹಾರ್ಡ್ ಕಾಪಿ, ಮೇಕಿಂಗ್ ಸಮ್ ಸಾಫ್ಟ್ ಕಾಪೀಸ್ ಇನ್ ಯೂಸಿಂಗ್ ಯುವರ್ ಪೆನ್ ಡ್ರೈವ್, ಆ ಥರದ್ದೆಲ್ಲ ಮಾಡಬೇಕು. ರೈಟಿಂಗ್ ಈಸ್ ಅ ವೆರಿ ಗುಡ್ ಹ್ಯಾಬಿಟ್ ಆಲ್ವೇಸ್. ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್. ನಾವೇನು ಮಾಡಬೇಕು? ಬರೀಬೇಕು. ಓಕೆ, ಒನ್ಸ್ ಓಕೆ, ಮುಂದೆ ಹೋಗುವ. ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಡೆರಿವೇಶನ್ ಇದೆ, ಅಫ್ಕೋರ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್. Five marks. Okay, 5 marks. Derivation ಏನು? Derive expression for derive expression for electrostatic potential, electrostatic potential due to point charge. Okay, very important derivation for finance. Spatially one charge is say source charge. We discuss the source charge. Okay, you are bringing some test charge from infinity and you place it somewhere at some point in the vicinity of that electric field. Then what is electric potential at that point due to the source charge is a question. Okay, so some basic ideas you need. Then some concepts of integration is very much required. Integration ಬೇಕು. ಓಕೆ, ನೀವು ಫಸ್ಟ್ ಇಯರ್ ಇದ್ದಾಗ ಕಲಿತ ಇಂಟಿಗ್ರೇಷನ್ ಸಹ ತುಂಬಾ ಹೆಚ್ಚು ಇಂಟಿಗ್ರೇಷನ್ ಏನು ಬೇಕಾಗಿಲ್ಲ. ಮತ್ತೆ ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ನೀವು ಇಂಟಿಗ್ರೇಷನ್ ಕಲಿಯಲಿಕ್ಕಿದ್ದೀರಿ ಈ ವರ್ಷ. ಸೊ ಡೋಂಟ್ ವರಿ ಅಬೌಟ್ ದಟ್ ಇಂಟಿಗ್ರೇಷನ್ ಪಾರ್ಟ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್. ಯು ವಿಲ್ ಲರ್ನ್ ಇಟ್, ನೋ ಪ್ರಾಬ್ಲಮ್ ಇನ್ ದಟ್. ಓಕೆ, okay. Now, visible. Let us consider a source charge, of course, plus and a test charge at infinity initially. Should not control. Okay, say I mean Q naught. Correct. Imagine you are supposed to bring it to the point A initially, then to point B. By moving it a small distance, say dx. Here dx represent very small distance between A and B. They are very close. If you move this object, this charge from A to B, of course you are doing very small work, small amount of work in moving charge from A to B. Let be dW. Here dW represent work done in moving a unit positive charge which is placed at A initially, moved through very small distance dx, so as to bring it to point B. Then you have to do work against the selected field. This work be dW. dW represent small amount of work in moving that charge, unit charge from A to B. Remember, initially it was placed at infinity, then you bring it to point A, then your derivation start. Now derivation will start. Ultimately, our aim is to bring this from infinity to some point, say P, which is distance r from source charge. The distance is like that, r from source charge. Okay. Let x be distance between source charge and A. Source charge and A. More distance is there. One distance, so source in the A given distance, so x. Another distance, so Q in the P given distance. Finally, P point ಏನು ನೀವು ಏನು ಮಾಡಬೇಕು, ಇಲ್ಲಿರೋದನ್ನ A ತರ್ತೀರಿ, A ದಿಂದ B ತರುವಾಗ ಎಷ್ಟು ವರ್ಕ್ ಮಾಡ್ತೀರಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಿ, B ದಿಂದ B ಇಂದ ಮತ್ತೊಂದು ಸಣ್ಣ ಪಾಯಿಂಟ್ C ಇರಬಹುದು, ಅಲ್ಲಿ ತರುವಾಗ ಎಷ್ಟು ವರ್ಕ್ ಕೆಲಸ ಮಾಡ್ತೀರಿ, C ಇಂದ D ಗೆ, D ಇಂದ ಹೀಗೆ ಮಾಡ್ತಾ ಸಣ್ಣ ಸಣ್ಣ ಸ್ಟೆಪ್ ಅಲ್ಲಿ, ಚಿಕ್ಕ ಚಿಕ್ಕ ಸ್ಟೆಪ್ ಅಲ್ಲಿ some small amount of work is done. Okay, in small amount, what we have to do? We have to move that charge. ಆ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡ್ತಾ ಬರುತ್ತೆ. ಓಕೆ, ಇಂಥವು ಎಷ್ಟು ಆಗ್ಬೋದು, ಎಷ್ಟು ವರ್ಕ್ ಆಗ್ಬೋದು ನಮ್ಗೆ ಗೊತ್ತಿಲ್ಲ. ನಂಬರ್ ಆಫ್ ವರ್ಕ್ ಆಗ್ಬೋದು. ಸಿ dw1 from A to B, dw2 from B to C, dw3 from C to D. ಸೊ ಹೀಗೆ ಸಣ್ಣ ಸಣ್ಣ ವರ್ಕ್ ಎಲ್ಲ ಮಾಡ್ತೀರಿ. ಕೊನೆಗೆ ಎಷ್ಟು ವರ್ಕ್ ಏನು ಮಾಡ್ತೀರಿ, ಸಮ್ ಮಾಡ್ತೀರಿ. Summation of all these works, dw1 plus dw2 plus dw3, ನಿಮ್ಗೆ ಏನು ಸಿಗುತ್ತೆ ಅವಾಗ? You get net work done, total work done in bringing that unit positive charge from A to B, or say infinity to P, whatever it may be, infinity to P. Infinity ಇಂದ P ನೀವು ಒಂದು ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಬೇಕಿದ್ರೆ ಎಷ್ಟು ವರ್ಕ್ ಅನ್ನು ಮಾಡಿದ್ರಿ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಿದ್ರಿ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಕರೆಕ್ಟ್. ಓಕೆ, ಇದನ್ನ ಮಾಡೋ ಮೊದಲು ಮತ್ತೊಂದು ವಿಷಯ ಡಿಸ್ಕಷನ್ ಮಾಡೋಣ. ಏನು ವಿಷಯ? ನಾನೀಗ ಹೇಳ್ತಿರೋ ವಿಷಯ ಈ ಡೆರಿವೇಶನ್ ಸಂಬಂಧಪಟ್ಟದ್ದಲ್ಲ. ಇಟ್ ಇಸ್ ನಾಟ್ ರಿಲೇಟೆಡ್ ಟು ಡೆರಿವೇಶನ್, ಕರೆಕ್ಟ್? ಬಟ್ ಇಟ್ಸ್ ರಿಕ್ವೈರ್ಡ್ ಫಾರ್ ಡೆರಿವೇಶನ್. ಡೆರಿವೇಶನ್ ಬೇಕು, ಕೋರ್ಸ್ ಬೇಕು. Okay, we don't think it is a part of derivation. Part of derivation Allah. It's a node. Just we have to know this. After that. Okay. See here. Okay, just note it. Okay, it is not part of derivation, but we need for derivation. Derivation is big. We need for derivation. It's not a part of derivation. Okay. We have source charge here Q. Right. Now, we have to bring some test charge from infinity, say plus 1 C, 1 coulomb from infinity, right? Now, we have electric field which is vector quantity produced by this charge Q, correct? And also electric force. I will write it as F ELECT, electric, in this direction. Correct? What is the relation between electric field and the electric force? We know. Electric field and field is equal to electric force divided by charge. This is a relation. You have studied in first chapter. ನೀವು ಇದರ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದ್ದೀರಿ, ಕರೆಕ್ಟ್? ಓಕೆ, ನೌ you are asked to, you are supposed to bring this charge from infinity to some point, some arbitrary point, say P. ನೀವು ಏನ್ ಮಾಡಬೇಕು? ಇದನ್ನ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ತರಬೇಕು. ತರುವಾಗ ಏನಾಗುತ್ತೆ? You have to do work against electric field. Electric field ಗೆ ವಿರುದ್ಧವಾಗಿ ಕೆಲಸವನ್ನು ಮಾಡಬೇಕು. Force applied by you in moving this charge, is called external force. ಎರಡು ಫೋರ್ಸ್ ಇದ್ದಾವೆ. ಒಂದು ಫೋರ್ಸ್ ಈ ಚಾರ್ಜ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದೆ, ಎಲೆಕ್ಟ್ರಿಕ್, F electric. ಮತ್ತೊಂದು ಫೋರ್ಸ್ ನೀವು ಹಾಕ್ತಿರೋದು, what you are applying. You are just applying so that you are moving that charge. That is the external force. External. We observe two forces. One is electric force, other is external force. Please remember one thing. This gravitational force, in case of gravitational field, this electrostatic force or Coulombian force Coulomb force, Coulomb force in case of electrostatic, both are conservative forces. They only depend on initial and final points, not actually path followed. Whenever we have conservative force, definitely there exists potential, maybe spring force, whatever it may be. Hope you understand. These two forces are opposite, represented by negative sign. ಇವೆರಡು ಫೋರ್ಸ್ ಏನಾಗಿದ್ದಾವೆ ಅಪೋಸಿಟ್ ಆಗಿದ್ದಾವೆ. Correct? We have two forces. One electric field in this direction, external force in this direction. Both are opposite to each other. Correct? Now, if this is okay, I will tell you something else. If you are moving, once again, let me close the. What about intensity? Okay. If you are moving this unit charge, in this direction, then what about work done? See here, we'll let somewhere here. Work done by external force, W external, is equal to F external into, what is the expression for work? Force into displacement. Say D, dr, whatever it may be, dr and cos theta. Dr cos theta. This is expression we have studied in first year. Name of the chapter is work energy power. In work energy power, we have studied expression for work done, where we represent work done as force into displacement into cos theta. Correct? Force into displacement into cos theta. Here, as we are moving in this direction, this is the direction of force, external force, and displacement. Of course, charge is moving in this. Okay, dr, whatever it may be. ನೀವು ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಅನ್ನು ಹಾಕಿದಾಗ ನೀವು ಹಾಕಿದ ಬಲದ ದಿಕ್ಕಿನಲ್ಲಿಯೇ ಚಾರ್ಜ್ ಸಹ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. The charge is moving in the direction of applied force. So there is no angle at all. Angle theta is equal to 0. Theta is equal to 0. If you put in this thing in this expression, external work will be F into D into cos 0, which is equal to F D. External work is equal to F into D. Force into simply displacement. Force into displacement. So, work done by external force in bringing your unit positive charge is positive. Now, what about your conservative force? Conservative force or electrostatic force. See here. This is source charge Q. Okay. This is the force direction, electric force direction, and this is infinity. Visible? This is infinity. Okay. I will write somewhere here. Shining up with board. Okay. I will write somewhere here. Here we have charge plus Q. This is infinity. We place some charge here plus 1 sig. And we are moving this charge in this direction. So, dr displacement in this direction, whereas electric field, electric force in this direction. Both are in opposite direction. Electric force produced by this charge is in this direction. Why? This is Q plus Q. displacement is in this direction, both are in opposite direction. Or angle between these two is almost 180. ಎಷ್ಟಾಗಿದೆ ಇದು 180 ಡಿಗ್ರಿ ಆಗಿದೆ. ಅವೆರಡರ ಮಧ್ಯೆ angle ಏನಾಗಿದೆ 180 ಆಗಿದೆ. ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಗಬೇಕಾಯ್ತು ಹಾಗಿದ್ರೆ W conservative ಹಾಗೆ ಬರಿಲ್ಲ conservative work ಅಂದ್ರೆ conservative work due to electric force W conservative is equal to ಏನಾಗಬೇಕಾಗಿದೆ F into D cos theta ಆಗಬೇಕು. ಫೋರ್ಸ್ ಎಷ್ಟು ಫೋರ್ಸ್ ಗಿಂತ ಹೆಚ್ಚು ನಾವು F electric ಅಂತ ಹೇಳಿದ್ದೇವೆ ಕರೆಕ್ಟ್ ಅಲ್ವಾ D displacement dr dx ಏನು ಆಗಿರಲಿ displacement. We are supposed to write all these things in terms of vector ಅಲ್ಲಿ ಬರಿಬೇಕಂತ ವೆಕ್ಟರ್ ಬರೀ ರೂಢಿ ಮಾಡ್ಕೊಂಡ್ರೆ ಒಳ್ಳೇದು. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ನಿಧಾನಾಗಿ ವೆಕ್ಟರ್ಗೆ ರೂಢಿ ಅಪ್ಲೋಡ್ ನಮ್ಮನ್ನು ನಾವು ಅಪ್ಗ್ರೇಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ವೆಕ್ಟರ್ ಅಲ್ಲಿ ಬರಿಬೇಕು ಎಲ್ಲವನ್ನು. ಓಕೆ, ಈಗ ವರ್ಕ್ ಅನ್ನು ನಾವು ಕಾಸ್ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಯಾಕೆ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಅಂತ ಹೇಳ್ತೇವೆ? ಥಿಂಕ್ ಮಾಡಿ. ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಹೋಗಿ ಐ ಮೀನ್ ಚಾಪ್ಟರ್ ಹೋಗಿ ನೋಡಿ, ಗೊತ್ತಾಗ್ತಾ ಹೋಗ್ತದೆ. ಎಫ್ ಡಿ ವಾಟ್ ಅಬೌಟ್ ಕಾಸ್ ಥೀಟಾ? Cos 180 because theta is equal to 180 degrees. What we get? WC is equal to minus FD. F minus FD. Cos 180 is minus 1. Cos 180 is minus 1. So expression for conservative work done by electric force is minus FD. That's why now you know F electric is equal to minus of F external. ಈ ರಿಲೇಷನ್ ಇರ್ತದೆ. F electric force ಇದೆಯಲ್ವಾ, ಅದು ಏನಾಗಿರ್ತದೆ? F electric force ಇದೆಯಲ್ವಾ, external force opposite ಆಗಿರ್ತದೆ. ಓಕೆ, ಈ ವಿಷಯ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. It is very important. It's very important. ಏನ್ ಮಾಡ್ತೇವೆ? We have to apply external force in a such a way that it is just enough to counter electric force. Electric force counter ಮಾಡೋದಕ್ಕೆ ಸಾಕಾಗಷ್ಟು ಹಾಕಬೇಕು. In other words, we have to move charge very slowly. Infinitesimally constant speed ಅಲ್ಲಿ ಮೂವ್ ಮಾಡಬೇಕು. ಅದು ಕಾನ್ಸೆಪ್ಟ್. ನೆಟ್ ಫೋರ್ಸ್ ಇರಬಾರದಲ್ಲ, ಈ ಫೋರ್ಸ್ಗೆ ಸಮನಾಗಿ ಫೋರ್ಸ್ ಅನ್ನು ಹಾಕಬೇಕು. To achieve this, what we have to do? We have to move charge very slowly. Theoretically, we have to move charge very slowly without acceleration. Without acceleration ಬರೋದಕ್ಕೆ ಇದು ಇದೇ ಕಾರಣ. This is one reason why we use without acceleration. Acceleration ಆಗಬಾರದು. There should not be some kinetic energy. Hope you understood. ಈ ಕಾನ್ಸೆಪ್ಟ್ ನಿಮ್ಗೆ ಗೊತ್ತಿತ್ತಂದ್ರೆ ಈ ಡೆರಿವೇಶನ್ ಈಸಿ ಆಗ್ತದೆ. ಆಕ್ಚುಲಿ ಟೆಕ್ನಿಕಲಿ ಹೀಗೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಎರಡು ಫೋರ್ಸ್ ಇರ್ತವೆ. ಸೊ ವರ್ಕ್ ಡನ್ ಬೈ external force is always positive. Work done by conservative force, I mean work done by conservative force is negative. Correct? Fine. In derivation ಮಾಡಬೇಕು. ನಾನು ಇಲ್ಲಿ ಸ್ಟಾಪ್ ಮಾಡ್ತೇನೆ ಅದು, ಯಾಕಂದ್ರೆ ಆಲ್ರೆಡಿ 33 ನಿಮಿಷ ತೋರಿಸ್ತಾ ಉಂಟದು. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದು ಡೆರಿವೇಶನ್ ಅನ್ನು ಮಾಡಿ ಮತ್ತೆ ಇದಕ್ಕೆ ರಿಲೇಟೆಡ್ ಕೆಲವೊಂದು ಪಾಯಿಂಟ್ಸ್ ಅನ್ನು ನೋಡುವ. ಆಕ್ಚುಲಿ ಇವತ್ತು ನಾನು ಏನ್ ಮಾಡಿದೆ ಅಂತಂದ್ರೆ ನಿನ್ನೆ ಕ್ಲಾಸ್ ಮಾಡಿದ್ದನ್ನೇ ಒಂದ್ಸಲ ರಿವಿಷನ್ ಮಾಡಿ ಒಂದು ಚೂರು ಮುಂದೆ ಬಂದಿದ್ದೇನೆ ಅಷ್ಟೇ. ಯಾಕೆ ನಿಮಗದು ಕನ್ಫ್ಯೂಷನ್ ಆಗೋದು ಬೇಡ ಅಂತ. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ವಾ? ನೀವು ಇವೆರಡು ವಿಡಿಯೋಸ್ ಎಲ್ಲ ಕರೆಕ್ಟಾಗಿ ನೋಡ್ಕೊಂಡ್ರೆ ಫ್ಯೂಚರ್ ಅಲ್ಲಿ ಮುಂದಿನ ಕ್ಲಾಸ್ಗಳಲ್ಲಿ ಸ್ವಲ್ಪ ಫಾಸ್ಟ್ ಮಾಡಿ. ಹೊಸ ಟೈಮ್ ಟೇಬಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಮತ್ತೆ ನಾನು ನಿಮ್ಮ ಗ್ರೂಪಲ್ಲಿ ಹಾಕಿದ್ದೇನೆ. ಅದು ಎಷ್ಟು ಅವರ್ಸ್ ಅಲ್ಲಿ 35 ಅವರ್ಸ್ ಅಲ್ಲಿ ಏನೆಲ್ಲ ಚಾಪ್ಟರ್ ಆಗಬೇಕು ಅಂತ. ಇದೇ ಸ್ಪೀಡಲ್ಲಿ ಹೋದ್ರೆ ನಾವು ಮುಗಿಸೋದಕ್ಕೆ ಕಷ್ಟ ಆಗ್ಬಿಡ್ಬೋದು. ನಾನು ಸೆಕೆಂಡ್ ಕ್ಲಾಸಲ್ಲೇ ಯಾಕೆ ಹೇಳ್ತಿದ್ದೇನೆ ಅಂತಂದ್ರೆ ನೀವು ಮನೆಯಲ್ಲಿ ಸ್ವಲ್ಪ ಪ್ರಿಪೇರ್ ಮಾಡಬೇಕು. ವಿಶೇಷ ಏನಿಲ್ಲ, ಓದಬೇಕು. ನೋಟ್ಸ್ ಇದೆ ಅಲ್ಲಿ, ಆ ನೋಟ್ಸ್ ಪ್ರಿಪೇರ್ ಮಾಡಿದ್ರೆ ಆಯ್ತು. ಕೆಲವು ನೋಟ್ಸ್ ಇರ್ತದೆ, ನೋಟ್ಸ್ ಅನ್ನು ಓದಿ ಬರ್ಕೊಂಡ್ರೆ ಆಯ್ತು, ಅಭ್ಯಾಸ ಮಾಡಿದ್ರೆ ಆಯ್ತು. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.